Hi guys, welcome to Vedant Education, where we solve math, science and engineering problems and learn the concepts. So today I have another question for you from GATE 2013. This question is on uniform plane wave from the electromagnetics, and here is the question. So a monochromatic plane wave of wavelength lambda equal to 600 micron. So 600 micron is the red light. Is propagating in the direction as shown in the figure below. EI, ER, and ET denote the incident, the reflected, and the transmitted electric field vectors associated with the wave. So they have two questions for the given statement linked question. So the angle of incidence theta I and the expression for EI R. So we have to find the angle of incidence and also we have to find the expression for EI. And the second question, the link question, is to find the expression for the reflected electric field. So we have to find three things in this question. So the first one is the angle of incidence, which is theta I. The second one is the angle of the electric field, incident electric field, the expression for that, and the expression for the reflected electric field. So let's dive into the solution. So the first thing we have to do here is to find theta I. So what is theta I in this question? So once you look at this question, to find theta I, you know that they have given this refracted angle, which is theta t. The theta t is 19.2 degrees. So if we apply Snell's law here, the Snell's law of refraction, we can find out what theta I is. So the first thing we want to do is to apply Snell's law of refraction. So the Snell's law of refraction states that if if you apply at this point, so the Snell's law says that Ni sine theta I, Ni is the refractive index of the medium, is equal to Nt sine theta t. So Ni, the refractive index of a medium, which is N, can be given as square root of permittivity. So in this case, the permittivity is already given here. So if we put these values into this formula, so the Ni is just 1 here, so it's root of 1 sine theta I is equal to Nt, which is a square root of 4.5, which is the given here, Er equal to 4.5. So let's just put it down here. So it's 4.5. So 4.5 sine of theta t, which is 19.2 degrees. Now if we solve this, we can find out the expression find the value of theta I. So let me just quickly find the value of theta I in my calculator. So theta I would be 44.23 degrees. So we know that theta I now is 44.23 degrees, but in the options which they have provided, they have estimated it to 45 degrees. So in options B and C, so let's just say that theta I is 45 degrees. So in the question, the options say that the theta they have given 45. So let's just estimate this 44.23 degrees to 45 degrees. So first thing is that we found out what is theta I. So the second thing is to find the expression for EI. So EI is the electric field, and the electric field of this wave can be written as EI, which is a vector, is equal to let's just say that E naught is the magnitude of this electric field. So E naught is the magnitude of this electric field. So if we write this, so if E naught cap were a electric field vector, which is this one. We have the phase term also, which is J, K, R, which is again a vector, right, R. So this is not R, so this is I. So the incident wave vector with the dot product of the R, which can be given as, so R can be given as x ax plus z az for the given problem. So we have to find what is the expression for EI. So let's first find out what is the wave vector Ki. So let's just write down the expression for Ki for the given problem. So let's just resolve the Ki along its components. So these are the components of the Ki. So since this Ki is in this direction, the components are like this, and we have to find out what this we have to write down Ki in terms of this component. So in this case, Ki here, this I will write the component along x direction, which is this one, and for that we need to know what is this angle. So since this is at right angles and this is theta I, this angle should be 90 minus theta I. So let's just write it down now. So Ki dash is equal to, so if Ki is the magnitude of this vector, Ki cos 90 minus theta I, and this is along the positive x direction. So Ax plus Ki sine 90 minus theta I, and this is in positive z direction, so it's Az. So we are writing the expression for this part here and this part here. So the total k vector is like this. Now if to find the magnitude of to find what is Ki, the magnitude of the k vector is just 2 pi by lambda. So lambda is already given in the problem, so it's 2 pi by 600 into 10 raised to minus 6 meters, which is let's just say that it's pi into 10 raised to 4 divided by 3. So Ki, the magnitude of Ki is this value here. Always while solving such problems, keep in mind that you don't have to put out the actual values completely. Just keep it in the simplest form, and you should find out the values when it's necessary. Otherwise, just keep it as it is. Then you you solve for Ki, and Ki we can get it the wave vector as Ki is already known here, and cos of 90 minus theta I and sin of 90 minus theta I, it can be rewritten as Ki is just pi into 10 raised to 4 by 3, and let's just put a bracket here, and cos, this is sin theta I Ax plus cos theta I Az. This equals to Ki is pi into 10 raised to 4 by 3 root 2 Ax plus Az. Now to find Ki dot r, we take this expression from here and this expression here, and from this we can find out the dot product of these two, which is pi into 10 raised to 4 by 3 root 2. It's just x plus z. So this is the phase of this electric field. Now let's find what is the magnitude electric vector here. So let's just write it down. So you can see that electric field is on the xz plane, and it's perpendicular to the k vector, so since it's a uniform plane wave. So since it's perpendicular to the k vector, and it's in the xz plane, which is the plane of incidence. It's a parallelly polarized wave. So now what we want to do is to write EI in terms of its components. So I'll just redraw this electric field vector EI here. So let's just redraw EI, and then I will resolve it along its components. So I am resolving it along its components, and what we can find here is, if this is just E naught, which is a vector, uh, this component here, if we know this angle here, so from the geometry you can find out the theta I, and from this component diagram, what we can get is E naught, the vector E naught is E naught. So this is theta I, that means this is 90 minus theta I, and this should be theta I. So E naught cos theta I, and this is x direction and this is z direction. So this is negative z direction. So E naught cos theta I ax plus E naught sin theta I ay, sorry, az minus az. So this, since this is in negative direction and this is in positive x direction and this is in positive minus negative z direction, we write it like this. So it's E naught cos theta I ax minus E naught sin theta I az. So if we solve this, so it's E naught by root 2 ax minus az. So we know what is E naught now. So let's just combine these two. So EI is equal to E naught e raised to minus k dot r, and when we combine these two, we will get the total expression for EI as E naught by root 2 ax minus az e raised to minus j pi into 10 raised to 4 3 root 2 x plus z. Okay, so this is the final expression, and let's just check whether we have this option in the given question. So we do have this option, which is the C option. We have 45 degrees of incident angle, and the expression is exactly what we derived here. So the next thing is to find out the expression for the reflected wave, so which is ER. So let's find the expression for ER in the next part. So once we do this, it's quite straightforward, but still you have to know a lot of important things before you find the expression for ER. Just make sure that you solve these all these equations logically to arrive at the expression. If you just look at the options and just choose something which you think is more likely, then you will definitely go wrong, because you have to solve this equation to get the answer to the end, and then you have to choose the option. Otherwise, in most of the cases, you will go wrong. Okay, so let's find the ER. So the expression for ER, which is a vector, is given by let's just say ER naught. It's a electric field vector, and e raised to minus j kr and r. So we know the kr vector we can calculate as before, but for a magnitude of the electric vector, we have to calculate what amount of light was reflected from this interface. To do this, we have a expression which is generally there for parallelly polarized wave for oblique incidence, which is given as the fraction of reflected light from a transverse magnetic wave, which is the given case, is which is ER by EI, which is the reflected magnitude of the reflected electric wave to the and divided by the magnitude of the incident electric field is equal to eta 2 sine eta 2 cos theta t minus eta 1 cos theta I divided by eta 2 cos theta t plus eta 1 cos theta I. So, so from the given problem, we know what is theta t, which is the transmitted angle, and we know what is theta I from previous calculation, since it's linked to the previous question. So, in this case, if you solve this, so Tm, if you want to solve this, so eta 2 is the impedance of the medium, of the transmitted medium. So, let us just say this is mu naught epsilon naught divided mu r epsilon r, and in this case eta 1 is equal to mu naught by epsilon naught, which is the impedance of the respective medium. So, if you plug in this into the given formula here for a parallelly polarized wave, we get mu naught mu r divided by epsilon naught epsilon r and cos of theta t minus mu naught epsilon naught cos of theta I divided by the same thing. So, mu naught epsilon naught mu r epsilon r cos theta t plus mu naught epsilon naught cos theta I. So, theta t is 19.2 degrees, theta I is 45 degrees, and theta epsilon r is 4.5. So, from this these values cancel out by themselves, since they are common in all of them, and generally mu r is 1. So, what we get is the reflected ratio is minus. So, let me I had calculated it before. So, let me just take it from there. So, it is 229. So, let us just from the options you can just make it estimate it as 0.23. So, it is a negative minus 0.23. So, the refracted magnitude is minus 0.23. Now, we have calculated what is the magnitude of the electric field reflected. Now, we will come to the expression. So, the first thing is to find the kr vector. So, here is the kr vector. So, again I will just I will just write down the kr vector here. If this is the kr vector, and we know that this is theta r. Okay, so from this kr we can write down. So, this is x and this is z, and we can write down what kr is in terms of its components. So, kr, if kr is the magnitude, kr, so this is theta r. So, along the z direction it is cos theta r minus az, because it is in the negative z direction, since this is positive. So, let's put it correctly. So, kr is this much plus kr, and it is on this component which is along the ax is sine theta r ax. So, since x is in the this component is in the positive x direction. So, kr is equal to kr cap is equal to kr by root 2, since theta r is also 45. So, kr by root 2 into ax minus az. So, this is the k vector, and then you find what is k vector dot r, kr dot r, which is kr by root 2 ax minus az, dot product of x ax plus z az. So this turns out to be kr by root 2 x minus z. So we know what is kr. It is same as for the previous solution where we found expression for ei. So this turns out to be, if we substitute kr, so it's pi into 10 raised to 4 divided by 3 root 2 x minus z. So we have found out what is k vector dot r vector, and now we have to find the magnitude of this reflected electric field, which is given here. So what I will do is I will just once again write down what is the r vector like. So it's here, this is er, and you will just resolve it along its components again. And okay, when we draw the er in terms of its components, this angle is theta r here. So let's just resolve it along its components. So er, let's just say er naught here, which is this one, equal to er, which is the magnitude, cos of theta r, and it's in negative x direction, which is in this direction. So it's minus ax plus, this is er, the magnitude, and it's sine of theta r, and again this is in negative z direction. This is the negative z and this is negative x. So this is minus az. So then we got er naught cap is equal to er cos, let's just solve it. So er by root 2 minus ax minus az. So this is the expression for er naught cap, and then we will write down what is the final expression for er. So let's just write down what is the final expression for er. It's er. So er, we know that er is 0.23 of the electric field, which is the actual incident electric field. So it's minus 0.23 ei, and it's minus ax minus az, expression of minus j kr dot r. So this is ei, which can be given in terms of the previous expression, which we have already solved, which is 0.2. So you can write down from the previous expression that the total electric field is 0.23 E naught divided by root 2 ax plus az, which we got from here, and then the expression for the phase factors in this case. From that we know, after solving this, we know that the option A in the given options, which is exactly what we derived here, is the correct one. So this the answers here are C and A. So thanks for watching. Please subscribe to our channel, and I have not checked whether these solutions are correct. Please tell me if I have done something wrong or any comments in the comment section below. Thank you.